This video corresponds to Lesson 5 in your student workbook on page 93. It's titled Rational Exponents, and we are in the second chapter, which is exponents, and remember that's part of the algebra strand. One thing I just want to mention, Lesson 4, which is called Scientific Notation, we skipped through that and you won't be tested on that in the math curriculum. Reason being, it's covered in the science curriculum. So we skipped right from Lesson 3 to Lesson 5. Okay, Lesson 3 was on integral exponents. So lesson 3 was dealing with exponents with negatives. And just a quick review from lesson 3, if I give you a variable with a negative exponent, we never give our final answer with a negative exponent. So you would always rewrite that to be a positive exponent. And if, for example, it was a to the negative 5, that answer would be 1 over a to the 5. So again, lesson 3 was on something called integral exponents, focusing on the negatives. What lesson 5 is going to be on? It's going to be on something called rational exponents. So you know from when we did numbers and number systems that a rational number is a fraction. So when I say rational exponents, they are also often call them fractional exponents. And what's going to happen is if I give you a variable with a fraction, we are going to do the same thing in the sense that just like I don't want you to write your final answer with a negative, you will never actually write your final answer with a fraction. And I'll show you how to get rid of that fraction. So what I want you to do is I'm going to teach you something called flower power. So at the top of your page, I want you to draw a straight line, which is going to represent the ground. I want you to draw some roots and then a flower. Okay, now in math, when you label this, write down flower, but in brackets, make sure you write the word power, because in math, there's no such thing as flowers, but it rhymes with powers. So what's going to happen is I'm going to give you a rational exponent. So I'm going to give you a variable or a number with an exponent that's a fraction. And what you have to be able to identify within this fraction is which number is the root and which number is the power. So how you're going to do that is if you remember this flower power, you know that roots grow below ground. So if this is your ground here, that 3 represents your root. And what grows above ground are flowers, which rhymes with power. So this 5 is going to be the power. So whenever I give you again a fractional exponent, I need you to be able to identify the power and the root. Then what's going to happen is the following. You're going to say, okay, this x to the 5/3 to the power of 5 over 3, what that is equal to, how we're going to write this is as a radical. And a radical, remember, is a square root sign. So what you're going to do is if you get a fractional exponent, you say, okay, I need to rewrite this as a radical. So draw your radical sign, and whatever your variable or your number is, that goes underneath your radical sign. The power is 5, right? The power is 5. So that's where we write powers. And roots go right here. So the root is 3. So how I would read this is the third root of x to the power of 5. Now, you'll see your workbook or solutions will give this as one method to write your solution. The alternate way to express your solution is you could say, take that x, put it under its radical sign. The third root will never change, but you could say, okay, this entire thing is to the power of 5. So I want you to draw, I'm going to give you one more fractional exponent, and I'm going to see if you could rewrite it as a radical using flower power. So let's say I gave you b to the power of 4/5. 4/5. So you'd say, okay, that's a fractional exponent. She doesn't want me to write it as a fractional exponent. She wants that as a rational number. So what you do is you write your square root sign. This is your base. It goes under your square root sign. And then you have to identify what's the root, what's the power. There's the ground. Roots grow below ground, so that 5 is the root, and roots will always go there. That's the fifth root of B. And then we say powers or flowers are above ground to the power of 4. So the fifth root of B to the power of 4, or again, the alternate way you could write this is the fifth root of B to the power of 4. Okay, so that's what this lesson is going to be on. Let's go down to C. So let's look at C for a second. Okay, I'm just going to rewrite this over here where I have more room. 25 to the power of 1/2. So the first thing it says, write the following in radical form and evaluate manually. Verify with a calculator. Okay, so let's do that. Write the following in radical form. So 25 to the power of 1/2, that's the same thing as take that base of 25 and put it under your radical sign. Then let's identify what the root and the power is. So the root is 2, and remember roots go here, and this is the power, and powers go here. Now, some of you will want to write that as the answer. However, there's a couple of things. Whenever we have a square root, we don't write that invisible 2, and you also don't need to write this invisible 1. So really, 25 to the power of 1/2, yes, this is what it is, but how you would actually write that is simply the square root of 25, because in here, there's an invisible 2 there and an invisible 1 there. Okay, so I'm just going to erase that. So the square root of 25, and then it says evaluate, and remember evaluate is find a numerical value, so the square root of 25 is 5. I just want to show you on your calculators, you could do rational exponents. So I could do this in one of two ways. 25 to the power of 1 divided by 2 gives me 5. The square root of 25 gives me 5. Okay? 64 to the power of 1/3. Let's write this as a radical. So 64 goes there. My root is underneath my ground, so my root is 3, and the power is 1, but I'm going to erase that 1, and I'm just going to have the third root of 64. Let's calculate what that is on our calculator. Let's actually punch both these in so that you get practice. So 64 to the power of 1 divided by 3 is going to give us 4 as an answer, or we could do the math button. Number 4 is our third root of 64. And remember, that third root tells you you're going to multiply 4 3 times, right? 4 times 4 times 4 is 64. So our answer is 4. 81 to the power of 1/4. That would be 81 to the fourth root of 81 to the power of 1, which I'm not going to write. Let's just type in 81 to the power of 1/4. Oh, actually, no, let me show you how to enter this on your calculator. The fourth root of 81. So you're going to enter the number 4, hit the math button, and then I'm going to select 5 now. So the fourth root of 81 is 3. Okay. D. Write the following in radical form. So I want you to pause this, and I want you to see if you could write each of these variables to a fractional exponent. Can you write each of these in radical form, just like I did up here, and then unpause it and check my answers? Okay, x to the power of 1/2 is simply the square root of x. B to the power of 1/3 is the third root of b. P to the power of 1/10 is the 10th root of p, and this one would be the nth root of a. All right, if we were given this, a to the power of m over n, and if I said, please express that as a radical, you would say, no problem. As a radical, she wants that base underneath the radical sign. Here's my ground. Roots grow below ground and powers are above ground. Or the nth root of a, the nth root of a to the power of m. Okay? Again, please pause the video and see if you could write for C. So please do C and rewrite each of these in radical form. So for C, um, there's my ground, the third root of x to the power of 5. There's my ground, the fifth root of b to the power of 4. I like this one. A lot of you will want to do this, the second root of p to the 5, but we don't need that 2, so you would erase that. And the nth root, the last one, the nth root of a to the power of m. Please flip to page 94. Okay, what I want you to write for here, just at the top of your page, write down 8 to the power of 2/3. So again, we could evaluate this in two ways. I could type this in my calculator. So let's go to our calculator. Let's clear what we have. 8 to the power of 2/3 is 4. Or I could say, I'm often going to say you need to express this as a radical. So let's express that as a radical. That would be, here's my ground, the third root of 8 to the power of 2. And we're going to type this in our calculator, and let's see if we get 4 as well. So the third root of 8 squared. So take out your calculators, math button, number 4, the third root of 8 squared is also 4. Okay, let's look at this. Use exponent laws to simplify. So we're just going to rewrite this so that we have a bit more room. So write down 8 to the 2/3 times 8 to the negative 2/3. All right, using exponent laws, bases are the same. So what I could do with my exponents is I could add them together because this is going to be product law. Now, in class, I'll tell you, whenever you have a fraction, I need you to put those fractions in a bracket on your calculator. And we're going to add these two fractions together because it is going to be, this is the power law, which we add the exponents. So let's add on our calculator 2/3 plus negative 2/3. So open bracket, 2 divided by 3, close that bracket, plus, open bracket, negative 2 divided by 3. And we get 0. So that makes sense, right? 2/3 plus negative 2/3 cancels out and we get 0. So that's going to be 8 to the power of 0. This goes to that 0 exponent law. And whenever you have something raised to the power of 0, the answer is 1. Okay, so that would be my final answer. Then it says, let's take 8 to the negative 2/3. So let's take this, 8 to the negative 2/3, and it says write it with a positive exponent. So just to review that, if I gave you, let's say, a to the negative 2, how did we do that in lesson 3 to write that as a positive exponent? You said, okay, that's a negative exponent. I have to write that over 1. As soon as I bring that a to the denominator, my exponent becomes positive. So that's 1 over a squared. We get to apply the exact same thing here, even if it's a fraction. The same rule applies for negative exponents. So if you want to make that negative exponent positive, do what you were told in the previous lesson, in lesson 3, and this becomes 1 over 8 to the 2/3. So to go from negative 2 to positive 2, you take the reciprocal. To go from negative 2/3 to 2/3, if it's in the numerator, you write it in the denominator. Now that would not be your final answer because you would say, okay, this has to be expressed as a radical. So that would be 1 over the third root of 8 squared would be your answer. Okay? Let's do class example 1, and then I'm going to give you your first set of homework, and that will be the end of part 1, and then we'll finish off this lesson in part 2. So class example 1 says write the following in radical form and evaluate without using a calculator. Then it says verify with a calculator, so we will use a calculator. Okay, this in radical form is going to be, let's see, the square root of 25 to the power of 3. I think what I'll do with you right now is let's rewrite each of these first in radical form, and then I'll give you your answers. Okay? Okay, for B, this would be, what would this guy be? The third root of 1,000 to the power of 4. This one has a negative exponent. So the first thing you have to do is write that with a positive exponent. So that would be 1 over 27 to the 2 over 3. So negative 2/3 is just 2/3 when you write it in the denominator. From here, we're going to say that's 1 over the third root of 27 squared. Okay. Same with D. Pause the video, see if you could write D. Oh, before I do that. Okay, so that's 1 over 16 to the 3 over 4. That's equal to 1 over the fourth root of 16 to the power of 3. E, how we would write that in radical form is because this is in a bracket, this entire thing is my radical sign. Then I'm going to figure out my flower powers of negative 8 in a bracket to the power of 2. This guy here, let's star F. Whenever you see, remember, a negative like this, what this really is negative 1 times 8 to the 2/3. Okay, that's how you would write that. And then from there, let me just give us a bit more room. From here, we would have negative 1 times the third root of 8 squared. And we're going to evaluate that. If you were to do G, according to BEDMAS, what you would do is you would evaluate, or you would take care of your brackets first. So within my brackets, I know what 3 squared is. 3 squared is 9. And I know what 4 squared is. 4 squared is 16, right? Then you would say, okay, I could further simplify this bracket. I could clean up 9 plus 16. 9 plus 16 is 25 to the power of 1/2. Write that as a radical, and we get the square root of 25. And the square root of 25 is 5. Okay? What I want you to do is I'm going to show you how to type in C. You should be able to type in A and B. So I'm going to show you how to type in C and E. We're going to do these two together, and then you're going to pause the video and evaluate the rest. So let's do C and E together. So C, 1 over the third root of 27 squared. So clear this. 1 divided by the third root is under your math button. So 4. And then it said 27 squared. Gives you this answer. And then what you simply do is math one fraction. And you get 1 over 9. So this answer is 1 over 9. I'm going to show you something that hopefully many of you sort of will make sense. Watch what happens if on my calculator I type in what they originally gave me. So let's type in 27 to the negative 2/3. 27 power negative 2 divided by 3, and I get the exact same answer. So The thing is, though, on a test or on a quiz, I would give you this and then I would say write it as a radical. That would probably be worth 2 marks. And then the answer itself worth an extra mark. So, yes, you could get the answer just by typing this in. How I could get you on a test to see if you understand this, though, is not give you the number 27 and give you a variable, right? Give you a to the negative 2/3 and say express that as a radical. So I need to see who's going to understand that. That would be a to the 2/3, and that would be 1 over the third root of a squared. Okay, let's evaluate e, and then you're going to do the rest on your calculator. So for e, the third root of negative 8 squared, how would I punch that in? So I'm going to clear this math button. Number 4, open bracket, negative 8, close bracket, square that, and hit enter, and you get 4. So this answer is 4. Again, I want you to do on your own A, B, D, and F. Pause the video, and then you could unpause it, and I will give you your answers. Okay, the answer for A, double check, I'm getting 125. The answer for B, I'm getting 10,000. We already did C. The answer for D is going to be 1 over 8. The answer for E we did, it's 4. The answer for F, when you evaluate this, you are going to get negative 4 for F. And we've done G. This is going to be your homework. I want you to circle this with me because I'll probably show you one more example with a negative just to make sure. So I want you to do in the homework 1 to 2, A to F. So let's go to that homework. Actually, for number 1, I said A to F, but I would like you to also circle I. Okay, so you should be able to do I easily. For number 2, I want you to do the same thing. I said A to F. Oh, there's no negative. Sorry, I'm just looking for if there's another example with a negative. And there's not. So 2A to F, and please do I as well. Okay, this is the other one. I'd like you to circle number 4 as well. So number 4, again, if it's within the bracket, that's going to be negative 8 in the bracket. It's going to be the third root. And then again, it really is to the power of 1, but we don't need to write that invisible 1. So this one, so for B, it would be in a bracket, negative 27 to the third root of that squared. Okay. Now, C, this has the negative and there's no bracket. So please write for C, negative 1 times 25 to the negative 1/2. And then this gets rewritten as a positive exponent. So this is going to be negative 1 times 1 over 25 to the 1/2. That's going to be negative 1 times 1 over the square root of 25. That's negative 1 times 1 over 5. And then if you check that on your calculator, negative 1 times 1/5, you're going to type in negative 1 times 1/5 in a bracket. So negative 1 times, open bracket, 1 divided by 5, and close that bracket. Math 1 fraction, and we get negative 1/5 as our answer. It says without using a calculator. I will always let you use a calculator. Okay? Try D and try E. And that concludes part 1.